When plotting the fundamental operation of adding, subtracting, multiplying, and dividing two functions, the situation is handled the exact same way as we would expect. So, let's say you start off with a function f of x equals 3x plus 1 and g of x equals x plus 2. Now, let's start off our discussion by adding, okay? So if you want to add these two functions, you would basically do f of x plus g of x. Okay, now simply what you need to do is replace f of x with the function of f of x and g of x with the function of g of x. So let's go ahead and do that. So you in bracket you would put 3x plus 1 plus bracket x plus 2. Okay, now the next step is to remove all the brackets and combine the like terms. But we would go step by step. Okay, x plus 2. Now you can spot the like terms here and like terms here. So simply just combine them, okay? That would be 3x plus x, that would become 4x. Now plus 1 plus 2, that would become 3. So this is the function when you add f of x plus g of x, okay? Now the notation for this could be also given as bracket f plus g of x. And this is the answer when we add function of x with function of g. Okay? So this notation is that you determine, okay, you describe the addition of the function like this that we just came across. Now adding to function is the variable x that is being involved. So you can't just write f over x over here because that would make the whole situation wrong. Okay? So the notation part is that f plus g, or whatever function you're using, okay, in this case it's f of x and g of x, so we combine these terms and put plus in the middle because we are adding, and you would do f plus g of x, okay? So let's move on to subtraction, okay? What if you want to subtract these two terms, okay? Subtract. Okay, what if you want to subtract these two terms? Now before we actually do the whole process, I want to show you the notation on how do we actually write the notation for the f of x minus g of x. Okay, now the simple way to write it is basically like this: f of x minus g of x, and we would all agree on this. Okay, but now since we said if we want to add f of x plus g of x, we would do this, right? And we all agreed on it. So why not, when we subtract, why can't we just go like this? Okay, so another notation that I'm introducing you guys to is f minus g of x. Okay, now if you want to do this, you can basically have this when you start off with. Then you can plug this in, which basically means the same thing. Now since I already wrote down this equations, I just want to subtract it. So it would be f of x, which is 3x plus 1 minus x plus 2. Now the tricky part here is that you can't just go down and combine the like terms, because there may be a possibility you might end up with a wrong answer. But sometimes it does work out. But we don't want to take that risk, okay? So what we want to do is, let's suppose this was negative 1, okay? This value is negative 1, and you're multiplying it by x plus 2. Basically, what you're doing is using the FOIL method. Okay? So let's do that. If you do that, you'd basically end up with 3x plus 1 plus negative x minus 2, right? And you would add plus in the middle because you already distribute the negative 1 times x, which becomes negative x, negative 1 times 2, which becomes negative 2. So the next procedure is very simple. You just combine the like terms. Okay, so let's move it over here. 3x plus 1 plus minus x minus 2 Now you would remove both brackets, plus negative x minus 2. 3x minus x is 2x, plus 1 minus 2 is minus 1, and there you end up with the answer. Okay? And remember that you need to, you can put this in a notation which looks like this or like this. Okay? It's up to you. In most of the problems you would give this, and you can substitute this in, which gives you this, and you need to multiply -1 on every, use the for method and add them, and basically you remove the brackets, then combine the like terms, and you would end up with your answer. Now suppose, let's say we take a different functions, okay? So let's get rid of this function because it's getting too main. Okay. Okay, so let's start that you would have f of x equals phi x minus 1 and h of x equals x plus 4. Okay, now let's say you want to subtract, you want to do this, f of f minus h of 7. Now recall that we used to say that if you have two functions, you can basically write f minus h in a bracket of x. Now here, they didn't give us x, but basically what they're trying to say is replace x with 7, okay? So that's what we want to do, and guess what guys? We're subtracting, so we need to subtract f of x minus h of x when x is equal to 7. Now there's basically two methods that we can possibly use. Let's go with the first one. Okay, so that would basically mean when f of 7 minus h of 7, right? So you would end up with bracket phi times x, which is 7, minus 1, close bracket, minus 7 plus 4. Okay, you would simplify this and subtract in the middle, that you would receive that 35 minus 1 minus 11. So 35 minus 1 is 34, 34 minus 11, which gives you 23. Okay, so this is the first method that we can use. Now the second method is basically how we used to say combine the like terms and plug in the value for x. Okay, so let's go ahead and do that. So for f of x, we have f of x minus h of x, right? That's what we have. Now let's plug in these things. Phi x minus 1 minus x plus 4. Use the for method, divide -1 times x, -1 times 4, you'll receive that phi x minus 1 plus -x minus 4. Okay, remove the brackets, combine the like terms, and you would receive 4x minus 5. Okay, now since we said the x is replaced with value of 7, let's plug in 7. 4 times 7 minus 5, you'll receive your answer to be 23. Okay, so this method that we just used is the second method to verify if our answer is correct or not. Another process that we can use is basically multiplication, right? So let's go ahead and do that. We talked about addition, we talked about subtraction, and we used various methods to describe that if our answer is right or wrong. Okay, so possibly there's two methods I just showed you can use. Okay, now since you're multiplication, now in the multiplication, remember that we said if you want to add, we do this. If you want to subtract, we do this. So what if we want to multiply? Well, basically, you would do this. Okay? F times g of x. Okay? That's what you want to do. Okay? So let's go ahead and do that. Use this function. So let's say on your test or whatever, they give you f of g of x. Okay? So you basically found out that it's f of x multiplying with g of x. Right? So the next thing you want to do is replace the function of x with this, and g of x with its h of x, my bad, okay? H of x with this function, okay? Now since we were using g of x too much, I mistakenly wrote that, but sorry guys, here, okay? So since we are doing this, we just need to replace its function, so let's go ahead and do that. And you would receive that it's phi x minus 1, you're multiplying it with x plus 4. Now it's basically using the FOIL method, okay? And you can use the FOIL method and then combine the like terms. Okay, so that's what you want to do. So if you do this, even in a calculator, if you plug in this, like TI-89, it'll give you the straight answer. But if you want to do it with paper and pencil or whatever, you can use the FOIL method, which is basically saying phi x times positive 4, then you go negative 1 times x, negative 1 times negative 4, and you would end up, then you need to combine the like terms, and you would end up with phi x squared plus 19x minus 4 is what you would have. And remember that this function notation is basically f times g of x. Okay, now since our last case is division, so let's go ahead and move on to division before we actually start solving some examples, right? So let's move on to division. We talked about addition, we talked about subtraction, we saw various methods to solve those things, and we replaced the value of x with 7, a number, okay? And we talked about multiplication. So now our next step is division. Okay? Division is basically easy to write. F divided by g of x. How hard is that? Okay? Now since in this case you're not using g of x, we can just simply write h of x. Okay? So that would basically mean that f of x, and you're dividing it by h of x. Okay? Now let's write this down. Phi x minus 1 all over x plus 4. Okay? And when you see a term like this, you need to find out its domain. Okay? You can plug in any value of x. Okay? On the top, it's all real number. Real number. But on the bottom, it can be all real number, because let's say if the value of x takes on negative 4, okay? If it does take on negative 4 plus 4 gives you 0, so the whole fraction would equal 0, and we don't want that, right? So we can say all real number except for negative 4, or we can just write x cannot be equal to negative 4, okay? And this is basically called domain. Okay? So that's basically it. Your answer is this. Now you can simplify as much as you want, but this is your answer. Okay? So let's go ahead and take a few examples to understand our core concepts before we actually move on. So before we actually move on to any other topic, let's go ahead and solve some extra examples, right? So let's say you start off with k of x equals x plus 1 and h of x equals 2x plus 9. And let's say your exam or test tells you to k times h of x, which basically, let's break this down. What does it mean? Well, this basically means that k of x is, when multiplied by h of x, what is the result? So what we need to do is plug in the k of x solution, x plus 1, multiplied by h of x, replace it with its h of x function, okay? And you use the FOIL method and try to figure out the answer. So let's go ahead and do the FOIL method here, okay? So x times 2x squared, then you would get plus 9x plus 2x plus 9. Add this like terms. Well, I see like terms here, like terms here. 9 plus 2, 2x squared plus 11x plus 9. So this over here is your answer, which is related to this. Okay? Now, one thing I forgot to tell you guys is, what if there's f fog of x, okay? Fog of x. Let's see, let's take an example, okay? So before we actually move on to any other example, our last example, let's just use different function to find out the following things, okay? So let's say you have f of x equals 4x minus 1 and g of x plus 5. Okay, so what we need to do now is basically, what if in your exam it says f of x and g f of x. Now this doesn't imply that we are multiplying it by another, okay? So this is the reason why I want to tell you the difference. Now since, if you recall, that we write f of x like this, okay? Like this. Now you see f over here. Now instead of g of x, it's basically trying to tell us that it replace x with the value of g of x, okay? So in the function of x, you replace the value of x with this function, okay? So how does that actually look? Well, that basically looks f of g of x. G of x is x plus 5. So how does that look? So that's basically 4 times x plus 5 minus 1. Okay? You would do 4x plus 20 minus 1 or 4x plus 19. Okay, so let's look at one over here. G of x means replace the value of x in g function with f of x, which is 4x minus 1. Okay, so it would be 4x minus 1. Then you replace 4x minus 1 plus 5. That would basically give you 4x plus 4. Okay, now another way to notify this is basically like this. So let me just go ahead and erase this up to tell you guys how do we actually write it instead of this. Okay, I'm going to write it in both of them so you guys get the concept. Okay, I'm going to switch the markers here. Okay, so instead of writing f g of x, we can also write this function as fog of x. Now this, I'm going to tell you, this O, which is small, does not imply that it's a 0. It's not 0, nor it's the letter O. Okay? It's not 0, nor it's a letter O. It's just, you can read it as gof of x and fog of x. Okay? So, it's basically like a multiplication sign, but in that multiplication sign, you basically circle the whole circle. In this, you don't basically circle the whole circle, you just make a small, tiny, medium-sized circle, okay? So, to remember this, it's basically easy. Whatever function you're writing that is over here, this function is implied to this one, and to imply this one, this function we can basically write as g of f of x. It's this function. Okay? So I hope you guys understand this concept. Now let's move on to our last and final example. So let's go ahead and move the board. Okay, so let's say they were giving you that find gof of x of y. What is that if g of y is equal to y plus 2 and f of y is equal to 2y plus 4. I hope you guys can read this. Now, says, let's write our functions down. This is a problem. G of y is given to us as y plus 2. F of y, in other hand, is given to us 2y plus 4. What we need to do is gof of y. Since our variable is y, it's not x, it's y. Whatever the variable is, it's that variable over here. Okay? So we can simplify this or cut this down as g f of y. Okay? To make us understanding more clear. Okay? Now it says for whatever value of f of y is, replace that into g of y. So we can basically write 2y plus 4 plus 2, or we can just write 2y plus 6. So this is the answer to the problem given over here on the top. Okay? So I hope you guys understand this tutorial.